plenary session 1 will begin. Let's welcome the first session chair, Professor Ming Li from National Tsinghua University, Hsinchu. Professor Ming Li.
It's really my great honor and privilege to introduce Professor George Apostolakis as a plenary speaker of this prestigious forum. Professor George Apostolakis now is the head of the Nuclear Risk Research Center in Japan. Professor got his bachelor from the National Technical University in Essen, Greece. Then he, at the year of 1969, and he received his PhD from the PhD in Engineering Science and Applied Mathematics in year of 1973, and he's a master in Engineering Science in 1970. Then he became a professor at the UCLA, and then he moved to MIT. George Apostolakis is really the most famous and the most important people in the probability safety assessment. Okay, he has served as a commissioner of the United States Nuclear Regulatory Commission from year of 2010 to year of 2014. That's exactly is over the year of the Fukushima events. Then during the year of 1995 and 2010, he was the member of and the chairman of the advisory committee on reactor safety of the NRC. George is also a member of U.S. National Academy of Engineering and a fellow of American Nuclear Society and the Society for the Risk Analysis. And he is the recipient of the Henry DeWolf Smith Nuclear Statesman Award from the American Nuclear Society and the Nuclear Energy Institute. Now today, he's going to talk about improve the safety of Japanese nuclear power plant by practicing risk-informed decision making. I think the risk-informed decision making is really kind of based on the probability safety assessment result. Well, after the Fukushima events, Japanese really important, the most important people and the most famous people in helping them to improve the safety operation of Japanese nuclear power plant. Today is really our great honor and the privilege to have him here.
So let me go to my slides. The subject of my talk is the improvement of the safety of Japanese nuclear plants that would be caused by practicing risk-informed decision-making. After the accident in Fukushima, there were many reports investigating the causes of the accident, the circumstances that led to the accident, and so on. One of the criticisms was that the utilities and the regulatory authority had not been utilized probabilistic risk assessments and risk-informed decision-making prior to the accident. And why was there such a criticism? Because it would have been a simple matter by doing a PRA, probabilistic risk assessment, to find out that putting the diesel generator tanks in the basement was not a good idea. So because of this criticism, the industry in Japan decided to establish the Nuclear Risk Research Center. That was in October of 2014. And the mission is shown on this slide. It's basically to assist the industry to manage the risks by developing and employing modern methods of PRA and risk-informed decision-making and risk communication. Now, what is risk-informed decision-making? All nuclear plants worldwide were originally designed and built according to traditional deterministic methods, in which probabilities play no role. There is a set of design basis accidents that are considered accidents for which the facility has to be able to withstand them. These are less than 20. And of course, the most well-known is the large loss of coolant accident. All these analyses are done in a deterministic way using equations and conservative assumptions. And also a major principle of the traditional approach is defense in depth, which means you should not rely on a single item to produce power and avoid accidents. In essence, it introduces redundancy and diversity. But over the years, we have found that this approach has drawbacks. And one of the most serious drawbacks is that it can impose unnecessary regulatory burden. And what do we mean by that? We mean that a lot of these requirements do not contribute much to safety. However, they cost the utilities money and resources. That's an unnecessary regulatory burden. And of course, there is always the issue of completeness. Have you thought of everything and so on? Now, on the other side, we have risk-based approach in which we use a PRA and we look at thousands of accident sequences as opposed to the limited number of design basis accidents. We quantify the probabilities of these sequences, so it's a much more realistic depiction of the plant. And of course, the issue of completeness is always there. Now, how can we take advantage of both and make decisions that are rational? This is the risk-informed approach, where we're trying to combine the best elements of the deterministic approach, defense in depth and so on, and margins, and the best aspects of the probabilistic approach, which quantifies probabilities and frequencies, identifies major contributors, and so on, and it looks at thousands of sequences. And of course, this combination has to be done in a deliberative way. In other words, it's based on the judgment of the decision maker. In the next slide, I show major areas of activities of the Nuclear Risk Research Center. The first, as I said at the beginning, the utilities and the regulator prior to Fukushima in Japan had been criticized for not taking full advantage of risk methods. So all of the utilities did have a PRA, but it was not up to the international state of the practice level. So we picked two model plants, one PWR, Ikata 3, and one BWR, Kashiwazaki Kariwa 7. And we formed, or we helped the utilities to form review groups, panels, consisting of international experts, mainly Americans and some Europeans. And these panels reviewed these PRAs and made extensive comments regarding completeness or the methods. And now these are only 2 units. The remaining units in Japan have agreed to follow closely these deliberations between Ikata and Kashiwazaki Kariwa with the international experts and proceed to make appropriate changes to their own PRAs. In addition to these international experts, the Center, NRRC, has also a permanent technical advisory committee consisting of 3 American experts, 1 Frenchman, and 2 Japanese professors. And this committee advises us on our research program, various models that we're developing and so on. And also it got involved in the reviews of the PRAs for Ikata and Kashiwazaki Kariwa. The second major area is we are developing guides for Japanese utilities to do PRAs in areas where there is a need for such guides. One very extensive guide deals with PRAs initiated by fires, internal fires. And the other one has to do with human reliability analysis, which is a field that keeps growing and changing worldwide. In both guides, we follow very closely the guidance that the Nuclear Regulatory Commission and the industry is providing to and the industry groups are providing to the industry in the United States. Now, of course, Japan has a unique characteristic. The risks from so-called external events like tsunamis and earthquakes and volcanoes are very prominent. So naturally, there is a lot of interest in developing PRA methods to handle tsunamis and so on. And that's where the center has extensive activities. And right now we're in the middle of, or near the end of developing a PRA method for tsunamis. And of course, the earthquakes are almost a permanent feature of our research activities. Another area of activity is training people and spreading the word of risk. And we are developing workshops and also short courses for utility personnel where experienced people give their views on particular subjects. On the next slide, I'm showing one major step forward in Japan. In 2018, we supported the utilities in drafting a strategic plan for the next many years. And that was updated in 2020. The remarkable thing about this plan is that it was endorsed explicitly by all Japanese utilities. And the main idea of RIDM, risk-informed decision-making, is shown in this picture from the strategic plan. It has 3 circles, yellow, green, and blue. The yellow circle is labeled 1. And basically it says that, the plant is operating fine, and then something happens. It's either a failure of some equipment or some new information comes to light that has an impact and so on. Something something happens that is outside the normal activities. So after that is identified, we move to the green circle 2, where we do the risk assessment. That means that we already have a PRA according to the international state of the practice, and we take this new piece of evidence, this failure, for example, and go to the PRA and see how significant it is from the risk perspective. And this is something that, as a matter of routine, is not being done in Japan now. This is new, to bring in the PRA. Of course, you also look at, in addition to the PRA, at regulatory requirements and anything else that may be relevant to this particular finding or failure. And all that information is moving to the blue circle 3, where the decision makers now look at all this analysis and they look at possible remedies, in other words, decision options to handle the item that was identified in yellow, in the yellow circle. And then they make a decision. So it's very clearly stated that the decision is the result of a combination of many diverse, sometimes, features. Risk is one of the inputs. The impact of the item on the PRA, the risk from the plant, is of course very important. But the decision maker also has to take into account the regulatory constraints, because of course we cannot violate the regulations. They have to also take into account the resources that are available. You don't want to expend too many resources on something that is not very risk significant, for example. And the availability of personnel to do it is also important. So all these things are taken into account in the decision as to which way is the best way to handle this finding. So that's why the process is called risk-informed and not based, because it's not only the results of the risk assessment that are taken into account, but all these other factors that I mentioned. And finally, on the next slide, we get an idea of the time scale for these activities. At the top, you see phase 1 and phase 2. The demarcation point is 2020. This is the year, last year, when the Nuclear Regulation Authority of Japan changed and accepted a new way of inspecting the plants, the so-called reactor oversight process, which is really almost a copy of the American ROP. Now, the significance of that year and the adoption of the ROP is that it has in it elements from risk. So it is the first time that the Nuclear Regulation Authority is actually using risk concepts in evaluating the significance of the findings of the inspections. So that's why there is a phase 1 prior to ROP and phase 2 after. So the utilities up until 2020, and even now, they have been very, very busy with restart efforts, because as you know, all the plants were shut down after the accident. And but after 2020, slowly we will start raising the issue of risk informing some of the regulations in Japan. Other than the ROP, we have no other regulation has been risk informed yet. And if you want to risk inform, it creates all sorts of additional issues. For example, do you need safety goals, or as we call them in America, quantitative health objectives and so on. So there is a whole new world that has to be visited in order to start using risk information in the regulations. So right now, the only place in Japan where some element of risk assessment is used is in the reactor oversight process. But we all hope that we will start making the case of risk informing specific regulations to the NRA, the regulator, in the near future. So this completes my presentation, and I thank you very much for your attention.